Right, Greg Perkins back with you on the Chapter 3 overview problems. So hopefully you've already worked on this, but if not, it's okay. Here we go. So first of all, here's the data, which is temperatures every hour for 24 hours. And to save some time, as usual, I already typed the data into the list, and we're going to be using the calculator for pretty much all of this. So find the mean, median, mode, and mid-range. So to do this, you have the information in the list, and then go to Stat, move over to Calculate, so move over by one, and it's the very first thing, one variable, statistics. So you can either type the number 1 or just hit Enter. And depending on the age of your calculator, it's either going to say this, or you would just say list 1. Frequency, just always leave that alone. And then go to Calculate. If you've got an older calculator, you saw just a second ago it flashed and said, well, 1, and then it gave me the answer. Well, that's how the older calculators do it. Anyway, so now that we've got the one variable statistics, the very first one is the mean. So we use X bar for the mean. So 46.750. And for the whole semester, I would request that you just use 3 decimals. You can see I've got 3 decimals right here. To set that, you just go to the mode and then change what's called the float to 3, hit enter, and then it'll be in 3 decimals the whole semester. Okay, looks like I need to get it back. Oh, by the way, this is what the older calculators would look like when you do the one variable statistics. It's just that slight difference. You hit enter, it gives you the same information. So another thing that we need is the, excuse me, I need to scroll down, the median. So the median, there is a symbol for it, but we use it so little you might as well just write out the word and forget about it, about the symbol. But the symbol X bar for mean, we're going to use that the whole semester. So the median is 44.5. That means if you put the numbers in a list in order from smallest to biggest, then there must have been a 44 and a 45 that were the 2 middle ones, and then 44.5 is in the middle of those two. And then the mode is simply the number or numbers that show up the most. So the calculator doesn't directly give you the mode, but if you put the numbers in order, stat, sort the numbers in list 1, then you can take a look and see if there's any that repeat. And whoever repeats the most is the winner. Not winter, winner. So let's see, there's 3 37s, so that's a winner so far. There's 2 of other numbers, but 3 37s is the winner. 50, no, not 59. Yeah, so it's those 3 37s. So the mode, the number that shows up the most, is 37. And then mid-range just means take the biggest number, which is 62, and the smallest number, which is 36, and average them. So it was a 36 and a 62, and then average those. So that's going to be 98 cut in half. Well, if it was 50 cut in, excuse me, if it was 100 and cut that half, it would be 50. Oh, why don't I just use a calculator? So it is 98 divided by 2. So 49. Next, find the range. So range is just the biggest number minus the smallest number. However, it's a very crude measurement of how spread out the scores are. So they go from a high of 62 to a low of 36. And if you subtract those, 62 minus 36, calculating this quickly in my head, it is 26. Then for what's probably the most important idea of Chapter 3, well, pretty close to. There's 2 very important ideas. One is this, standard deviation. So actually the calculator showed us that earlier when I did the one variable statistics, and that is the S. So this is a measure of how spread out the scores are. If this number is very big, then the numbers are very spread out. Like there's one number that's a 2 and one number that's a 200. That would mean the standard deviation is big. If the standard deviation was small, for example, if S equals 0, then all the numbers are exactly the same. So this is sort of a medium situation that the standard deviation is S equals 8.989. And then variance is something that we're not really going to use until later in the semester, but you just take that number and square it. And that's the variance. So just take a 8.989 and then squares over here on the left. 80.82. Next, find the temperature at the 28th percentile. So if you were to take the numbers and put them in order from the very lowest, that's 36, to the very highest, that's at 62, then this is basically saying, well, somewhere about here, this is 28% of the data. So those are the 28% coldest temperatures, and then the question is saying, where is this cutoff line right here? So basically, you just have to find 28% of how many numbers we have. We had 24 numbers because it was over 24 hours, so n equals 24. N always represents the sample size, so n equals 24 here. And to find 28% of something, you multiply by 0.28. So it's called the locator, although you don't really have to remember that it's L. Find 28% of 24 numbers. So 0.28 times 24 is a 6.72. So in other words, go to the list, start with 36, and count until you get to the 6.72 number. Well, there is no such thing, so what we have to do is round up. So no matter what decimal this is, if it was a 6.02, you still round up. So use the 7th number. And then we need to go back to the list. Once again, have the list in order. And go to the 7th number. And it is whatever the 7th number is. The 7th number happens to be a 39. So that's going to be the answer. So the 28th percentile is when the temperature was 39 degrees. Now the question is asked the other way around. So if you were going from 36 to 62, and now the cutoff is at 37 degrees, now the question is saying, well, what percent is this? What percent? So it has to be those that are lower than 37, because you can't include the 37 because we're saying that's the cutoff line. So what's left or lower than 37? So once again, it's helpful to have this in order. So I have to start from the beginning. Whoops, go back. If I go down and down, it'll be at the top of the list. And there's actually only two numbers that are less than 37, those two 36s. So that's two numbers. So that's two numbers out of the possible 24. So 2 out of 24. If I divide these, it will give me a decimal. The problem is asking for a percent. So then I need to multiply by 100 to make it a percent. So that's going to be 2 divided by 24, and then times 100. And that is the 8.3%. So for this one, we use just regular rounding rules. With a 0.3, that's not enough to move it up to 9%, so we say it's 8%. I'll just put an arrow because it's not really equals to this. It got rounded to. It is percentile 8. Or in other words, 8%. And let's see, what else do we have? For this data, create a box plot. So a box plot simply uses 5 numbers on a number line. On this side is the lowest number, which was the 36. Over here is the biggest number, which is 62. And then for the numbers that are in the middle, we need to go back to the calculator. And look at when I found the mean and standard deviation. Well, there were a bunch of other numbers there. If you scroll down, these are actually the 5 numbers that are used. So the minimum is 36, the biggest is 62, I already have those on the graph. Then we need the first quartile, or in other words 25% of the way through the data, the middle, and then 75%. Now, in order to place these numbers properly, what I'm going to do is I'm going to take this away for a second, and I'm just going to look at this part. So first of all, I don't want to have to put little hash marks and count 36, 37, 38, 39, etc. But just to get an idea, what's like halfway between 36 and 62? Well, actually, we did that earlier because we averaged 36 and 62 right here. So halfway between a 36 and a 62 is a 49. And then what I'm going to do is just lightly in pencil. So in the middle is a 49. So that's not really a part of the box plot, but it helps me to figure out where do I put these other numbers. So for example, the quartile, the median right here, 44.5, that would be to the left. That would be approximately right here. And then label that 44.5. And at 38.5, well, if this is 36, 38.5 is approximately right here. And then for the third quartile, or in other words, 75% of the way through the data is at 54.5. So that I would put about right here. And then for these middle 3, you put a box around that, and then that is the graph. And then the last thing that I need to do is erase that 49. Well, I can't seem to find my eraser right now. So just pretend that I erased that 49. Just ignore it. Hey, the other thing that I wanted to do is use the calculator. So here we go. The calculator can do the same thing. So what you need to do is go right here to second stat plot. You can choose number 1 and turn it on by hitting enter. Next, go down by 1, and there's 6 types of graphs it can make, and we're doing this one. So if you go to the right, it'll get to this one, which is the box plot. Hit enter. Next, tell it where the list is. So mine's in second, list 1. Once that is set up, go right here to zoom. I'm not sure why the calculator did that. Oh well, I'll just have to do it myself. Okay, so I would need to go into the window and basically enter these numbers, or something close to it. So I need to make the window a little bit smaller than 36. So let's say 30. And then it has to go past 62, so let's say 70. And then I think this could go from 0 to 10, and we'll be able to see the graph. There's the graph. And then, so you can see this bar right here is shifted to the left because 49 was in the middle, and that bar is shifted to the left. This one is also farther to the left, so it's like that. Anyway, if you also put trace, hold on, there's something else on my calculator. Okay, we're back. If you press trace, then you can see the different numbers. So go from the left to the right or right to the left with these arrow keys, and you'll see the same numbers that we have on our graph. So that one's done. Next, the other extremely important idea of this chapter, the z-score. So basically, the z-score finds out how many standard deviations from the mean is a 59. So earlier we found out the average, that was way back on part A, is 46.75. And then on part B we found out the standard deviation is 8.989. So as you can see, 59 is above average. 46.75 is the average, 59 is above it. If you add this standard deviation onto this, it's going to be approximately 55. So that is still above one standard deviation from the mean. So exactly how many standard deviations is it away? Well, here's the z formula. It goes, take the score, which we use the letter x for that, minus the mean, divided by the standard deviation. Extremely important idea. We're going to be using it in many different ways. So in this example, it would be z equals the score of 59 minus 46.75 is the mean, divided by 8.989. So then, using our trusty calculator here, I need to put parentheses around the top so that this is in the numerator. 59 minus 46.75, and then it's divided by 8.989. So that's a z-score of 1.363. And then, assuming that there's a normal distribution, so in other words, the average would be right here, then for unusual, that means you go 2 standard deviations above the mean, that's 2s. Or if you go to the left, it's going to be the mean minus 2 standard deviations. And if this is a normal distribution, then 95% of the data is between those two. So that means there's only a 5% chance that it would be beyond these two numbers. That's considered unusual. So we just need the mean, which is 46.75 plus 2 standard deviations. And then we need 46.75 minus 2 standard deviations. Don't you just love math? And then with the calculator. So we have 46.75 plus 2 times the standard deviation, 8.989. So that's 64.728. And then look, here's something neat. If you want the problem back again, depending on the version of your calculator, with some of them you could just press the up arrow key like this, and then you can get it back if you hit enter. If you have an older calculator, you just put second enter, and it will give you the problem back again. And then you can just put subtract, and don't have to retype it. 28.772. So that means if a score was above, or a temperature was above 64.728, or if it was below 28.772, it would be considered unusual to be either that hot or that cold. And then for the last one says, here's a table of age distributions from some of my previous students, and then find the average. Well, the problem is, with the average, you're supposed to add up the ages and divide by however many people there are. Well, we can see there's, 27, with this would make it 37, with 5 makes it, there's 42 people. But the problem is we don't have the actual individual ages. So what we have to do is say, well, these people that are 17, 18, or 19, so if you have 17, 18, and 19-year-olds, some are going to be 17, some 18, some 19. So what I'll do is I'll just use the middle, which in this case is going to be 18, and I'm going to say they're all 18-year-olds. So that means I have 12 people that are 18 years old. And then you just multiply those two. So I have 12 people that are 18 years old. Next, for this one would be 20, 21, 22. So the middle is 21. So I have 15 people that are 21. Okay, this one's done. Next, the middle number here is 24. So plus I have 8 people that are 24. The middle number is 27, so plus 5 people that are 27. And then this one is extended a little bit because this is 29, 30, 31, and 32. So the middle number is actually right here in the middle, which is 30.5. So I'd have plus 30.5, and I've got 2 people that are like that. Now, since this is years, and I've got 12 of them, then this is a total number of years, and years, and years, and years. So this is the total number of years. If you divide by how many people there are, then you're dividing out this people information, and you're leaving just years. So in other words, you divide by the total number of people, 42. So 12 times 18 plus 15 times 21 plus 8 by 24 and 5 times 27. I said 27 times 27 plus 30.5 times 2. That's a grand total of 919 years, but there's nobody that's 919 years old. That's for 42 people. So if you divide that by 42 people, it will tell you their average age. So the average age of that class, last semester's class, is just under 22 years old, 21.881. Okay, that's the math fun for today. See you next time.